Okay. All right, so after this, we'll do another one. You know, if we don't get to chapter 4 today, that's fine. We can always start it next week. I do have office hours today, remember, from 2 to 3. Okay. So here's another one. And again, the names I chose kind of randomly. Let's suppose Adam has $100 in a school lunch account. And the school charges $3.50 per lunch. The question is, how many lunches can Adam purchase? Okay, so we read the problem. So what's changing? What's changing here? What quantities are changing? Well, how much money Adam has in his account and how much money he spends on buying lunches. Right? Every time he buys a lunch, it costs Adam money and he loses money from his account. So just like the previous question, we're gonna let M, we're gonna use some notation for how much money Adam spends or Adam has in his account, or in this case, it's how much he spends. And X is how many lunches he purchases. Because those are two quantities that are changing, how many lunches he buys and how much money he spends. Again, those are two quantities that are changing here. Good. Okay, well, it may not be obvious how we're gonna approach this. Well, let's play around with some numbers to see what's going on. So, can Adam buy one lunch? Well, one lunch costs $3.50. Well, he could definitely buy that, right? He has $100. And how much does he spend? $100 minus $3.50, which is $96.50 he has left over. So yeah, he could definitely afford one lunch. Can Adam buy two lunches? Not two more lunches, two lunches. So $3.50, right? He has that. And he's buying two, and that would cost $7. You know, multiplying. Well, can he afford that? Yeah, he has $100, so he would have left 100 minus 3.5 times 2, which is $93. So he spends $7. That's what M is. Right? In terms of our notation, this is what M is up there. That's M. But can he buy 50 lunches? Well, that would cost him 3.5 times 50, $175. Well, he doesn't have enough money, so there's going to be a limit to how many lunches he can buy. Okay, well, how are we going to know? How can we determine how many lunches he can buy? He can only buy $100 worth of lunches, right? Because if he goes beyond $100, then he's not going to be able to afford it. Okay, well, if we go back to our notation, M is how much he spends, how much Adam spends, right? So we want to know when M equals $100. X is how many lunches he buys, and we're basically trying to find X such that M is $100, right? Because if X here were 50, M would be $175, which is too much. He doesn't have that money. He doesn't have that much money, I mean. Okay. Right, if we put our notation in, if you look at the problem, the lunches is X, right? And M is how much he's spending. So we basically want X so that M of X is 100. You know, he can't buy more than $100 worth of lunches. So how many could he buy at most? The number of lunches that he can buy is such that M of X is $100, is 100. So we have to solve this equation then. We want x so that this is true. Okay, so what do? We have that equation. We have our pathway to solve, that is, and we solve it. You know, here it's actually pretty easy. We just divide by x, 3.5. So this cancels with this, and we get x on the right side. Well, we get x, and we get 100 over 3.5. So x equals 100 over 3.5. And that turns out to be about 28.6. So he can buy at most 28 lunches. So he can buy at most 100 lunches. He can buy, at most 28 lunches, okay? Because 28.6, then m of that would be 100 about. And he would spend $98. Okay, so that's this word problem. Are there any questions on that? Okay, so I figured now would be good then to move on to chapter 4. Right, chapter 4, I did send the notes. Chapter 4, we're gonna go into now. Again, word problems in the past, I haven't put them on exams. They could be on homework, but I don't expect to put them on exams. This is chapter 3 we're in now, and the first test again is on chapters 1 and 2. And again, when it's posted, I'll let you know. I'm not done yet though, so not done yet today, I mean. So let me get the notes. Okay. So I figured now would be good to start the next section, which is percent. So let me share the screen. Here it comes. And here it is. Okay, good. So we're going to start this, which is percentages. Percentages you do encounter on a daily basis. You know, you might hear something like, you know, in the news, 28% of the people voted for Biden or something. I don't know. I just made that up. Maybe not the best example, but hopefully you understand what I'm saying. 90%, the vaccines, for them to be they have to be 95% effective for the public to be able to have access to them. You know, that was in the news. You know, what did they mean by 95%? That's it. You know, you might see at a store, there's a sale, the price has decreased by 25%. But what's up with all these percentages? What does it mean? Well, percent alone means per 100. Per 100. Another way of saying it is to say we have B percent, where B is a number, we really have B divided by 100. Or maybe this might be easier. B percent is really the same as B over 100. So 95% is really 95 over 100, which is 0.95. It's generally easier to think of it as a decimal. You could write it as a fraction, but it's probably a little bit easier to think of it as a decimal. Okay. I mean, that's the idea with percents. We're going to see how to work with them. You know, we have also this B percent as a number is B over 100. B is just a number. But when you have B over 100, that's the same thing as moving as a decimal. You're moving to the decimal to the left 2 spaces. And really, that's what we have here. To convert a percent to a decimal, as I have in the examples, you're going to move the decimal point 2 spaces to the left. I mean, what's actually happening is if you have B percent, you really have B over 100, which as a decimal means you move the decimal point 2 spaces to the left. And to go the other way, if you have a decimal and you want to convert that to a percent, you're going to move the decimal point 2 spaces to the right. For example, to say 45% is the same as 0.45, right? You move the decimal 2 spaces to the left, which is the same as 0.45, or if you want as a fraction, 45 over 100. B in this case would be 45. Okay. And 0.98 as a percent would be 98%. You move the decimal 2 spaces to the right. That's what they mean by 98%. Okay, so those are, I mean, that's what percents are. But to actually work with them, we're going to use these ratios. Excuse me, we're going to use these fractions. That's better. Equations, that's better. Equations. Essentially, when you have a percent and you want to work with it, you convert it to a decimal, which is what this slide was telling us. And then you're going to use either one of these two equations. For instance, you can have percent as a decimal equals part over whole, or it equals is over of. Equals is over of. Part over whole. This is especially useful when you have word problems to work with. For instance, you might ask, what is 98% of 3,000? You know, so if you had something in the store, I don't know, like a pair of jeans, originally it was $30, and now you learn that it's 25% off. Well, what would the new price be? You're going to have to use these equations, one of these, that is. I mean, that's what we're going to deal with. That's what we're going to do.